All right, next up are exponential functions. And exponential functions are in the form f of x equals a to the x power, where a is a number that is greater than 0. So a is a positive number. The base is a positive number. And also a cannot equal 1. If we had 1 to the x power, well, 1 to any power is just 1, so that would be a constant function, which is not particularly interesting. There are lots of exponential functions. The most classic one is f of x equals 2 to the x. That's generally the first one that students look at. Let's make a quick graph of this. All right, so if we have f of 0, 2 to the 0 is just 1, because anything to the 0 is 1, except 0 to the 0. If we plug in 1 here, f of 1 is 2 to the first, and 2 to the first is 2, so that gives us the point 1 comma 2. If we evaluate this at 2, that gives us 2 squared, which is 4. If we evaluate this at 3, 2 to the third power is 8. And as we continue adding to x, making x larger, we end up getting larger and larger numbers. So this is growing exponentially. That's where exponentially comes from. And then if we look at negative values of x, remember that a negative exponent gives us a fraction. So if x is negative 1, 2 to the negative first is the same as 1 over 2 to the first, or 1/2. When x is negative 2, that's going to be 1 over 2 squared, or 1/4. Negative 3 is 1/8. And as we move to the left, the x values end up getting smaller and smaller and smaller, but they're always still positive. They never drop below the x-axis. They never get negative, and they never actually become equal to 0. So we have an asymptote here. The graph is asymptotically approaching the x-axis. I've done my best to draw that, but of course we get eventually to a point where the marker that you're using, or the pen that you're using, the width of the ink is larger than the distance between the graph and the x-axis. So it does get really difficult to draw things like this, but we do our best. So this is a graph of a very basic exponential function. You'll notice that the domain here is all real numbers, which is true for all exponential functions. And then the range here is not all real numbers. We can see that the range goes from 0 to infinity, not including 0, because we never actually end up touching the x-axis. Now, this is just one exponential function. There are all sorts of exponential functions. There's lots of things we could pick for our base. There are some that are particularly common. One of those is e to the x, where e is a constant approximately 2.71828, and it goes on and on. It's an irrational number. And another one that can be quite useful is 10 to the x, specifically because we use a base 10 number system. So that ends up being useful. And in fact, we see powers of 10 with scientific notation. So there are a lot of good reasons to look at that exponential function. We can also have bases that are much smaller. Only positive numbers, remember, but we could, if we wanted to, look at f of x equals 0.5 to the x power. It's the same as 1/2 to the x. And we get a graph that looks a little bit different when our base is less than 1. I am not going to take the time to draw the most accurate fancy graph here, But what we end up getting in a situation like this is a graph that goes up exponentially to the left and then approaches the x-axis asymptotically to the right. So this is a very, very rough sketch of 0.5 to the x power. So they don't always look like our original one. If the base is larger than 1, they will go up exponentially to the right. But when the base is between 0 and 1, they will actually be going up exponentially to the left. Just a neat little tidbit there that not everyone is familiar with.